Someone coming to that. Hello everyone, my name is Abdul an information student, an information system student with a student ID 3242 to 044. Today I would like to present my practical report on the big data introduction first within the project end-to-end Bitcoin price data engineering and predictive model using RMA. In this presentation, I will walk you through the complete data science, the complete big data science lifecycle that I implemented across two vertical sessions. This includes dynamic data ingestion via a web API, comprehensive data cleaning and statistical testing, model optimization, and finally, forecasting future asset prices using the ARIMA. Alright, now let's move into the first session, that is data engineering. We started our first practical session by setting up a dynamic outline. Instead of using a static CSV file from the start, we started real-time data directly from the internet. Using the request library, we connected to CoinGecko API endpoint. We specified our criteria using query parameters. We requested Bitcoin price to be denominated in US dollars, covering a historical timeline of 90 days with a daily resolution interval. And after validating a successful HTTP response to the scope of 200, the raw GSRN payload was paused and we isolated the nested price data. Next, we loaded this data into a pandas data frame. The raw data from the API contained complex units timestamp in milliseconds. To make this readable and ready for analysis, we transform this command into a standard human readable time 64 format. We then conducted data cleaning by filtering out unnecessary columns, by dropping potential duplicate entries, and removing any missing values using job node. As a final validation step of vertical 1, we executed the TF info to cut inform what kind of output or what kind of information that we could get from this data. The output confirmed a perfectly healthy and balanced data set consisting of exactly 90 rows and 91 rows with zero missing values ready for the next phase, that is time series analysis. But before that, we also describe the DF and save the file into the CSV file. Alright, next we move into the next phase, which is time series analysis or the ARIMA implementation. Here we first we importing the library. In here we import the standards, non-binary topic, and also there are some statistical models that we use in here. That is the Laporan for ICF and for ACF for the visualization, and also we importing the ARIMA. However, before passing any data into ARIMA, we must satisfy a critical statistical requirement. Stationary time series is stationary if its mean inference remains constant over time. Looking at our initial historical line path, we observe price peak over so we could clearly observe a strong macroeconomic trend by seeing the initialization visual that the price peak over 80,000 USD and then sharply declined towards the late June. This result strongly suggested that our data was non-stationary. To prove this scientifically, I will a custom Python function to run the augmented DTA layer or the ATF test. The initial test on the raw price data return a p-value of 0.921. which is way above our 5% significant threshold. This confirmed that the raw data was indeed non-stationary. To resolve this, we applied a mathematical transformation called the first order differential, where we subtract the previous day price from the current day price. When we run the ATF test a second time on this transform data, then it quickly dropped drastically to nearly zero. In here, to nearly zero. Here, 3.82 E times minus the 10. Right. Nearly zero. Furthermore, our new line plot showed the data fluctuating randomly around the mean of zero. This means our data has officially become stationary and we lock in the integration parameter d is equal to 1. Alright. And then with our data stabilized, we needed to identify the remaining parameters for ARIMA. P for the P for the outer regressive component and Q is for the moving average component. We plotted the autocorrelation function or the ACF and the partial autocorrelation function of the ACF graph. Both showed a sharp drop off where the correlation spikes immediately and the blue shaded confidence interval of the lag zero. This baseline pattern allowed us to experiment with a standard development length around 111 model configuration. We initialize the model and call the fit function to compute the optimal statistical weight. Looking closely at the model summary output, we can see that both the AR coefficient and at the zero, uh, at the AR coefficient and the MR coefficient return highly significant p-values of less than 0.05. More importantly, diagnostic tests like the June box and probability is on the 0.56, proving that the model's residuals are completely free of autocorrelation. The errors behave like pure white noise, indicating that our numerical model successfully extracted all usable historical patterns from the data. In the final phase, we evaluated our model performance. We generated an in-sample forecast and plotted it against the actual historical data. As shown in the graph, the red dashed line representing our forecast closely mirrors the blue line of the actual prices, so it exhibits a slight when the lagging, which is highly typical for financial assets modeling. Our residual distribution also forms a neat bell-shaped curve centered at zero, proving that our model is unbiased. Finally, we utilize the model to perform a sample forecast projecting Bitcoin prices for the next 5 days into the future, from June 28 to July 2nd. Because the historical period ended on a heavy downward momentum, the area model mathematically projected a smooth gradual consolidation curve, predicting the price to settle around 60,500 to 60,100 USD range. The platform seamlessly staged our historical past with the newest 5 days predicted horizon. To conclude, this project will successfully demonstrate a robust state. After we visually the forecast of the Bitcoin prices for 5 days in the future, we can declare the data frame of this forecast to save it in CSV later in here. Alright, To conclude, this project successfully demonstrates a robust data pipeline which transitions from raw web data extraction to a fully informed, statistically sound predictive model. We learned how to handle non-stationary we learned how to handle non-stationary uh, financial data through differencing accumulated zero accounts and generating the different future projections. That concludes my presentation. Thank you very much for your time and attention.